All right, so the second video is to do the percent composition problems, and then also one with a hydrated sample that is heated to remove the water. So we already went through a lot of examples in our notes, but percent composition should be pretty easy, because anytime you do a percent, you're really doing the same things, right? Any percent from any context is always a part divided by a total, and then you take it times 100 so you can get your percent, right? So all I need to know in context is, okay, ammonium carbonate, that's that thing we already did in the notes, which is kind of important because I need to know the mass of this thing, the total mass. And I already calculated that once, so I didn't want to waste more time. So we added that up before and found out that it was 96.11 grams per mole, right? Now the only trick to this is I want to know what part of that mass, 96.11, is nitrogen. So there's two nitrogens, remember? So I just take 2 times 14.01, that'll give me 28.02, and then I'll divide that by my total and take it times 100. That's as simple as it gets. So when I multiply here, or excuse me, when I divide and then multiply by 100, I should get an answer of 29.15% nitrogen. I also talked in class about what to do with that, right? Why we would want to know that, because it turns out a secondary problem, so I'm going to insert a page here, and maybe you should put this answer in your notes, would be to tell you that you have 5 grams of ammonium carbonate. Can't spell right now. Ammonium carbonate. And in that 5 grams, how much of that is nitrogen, right? How many grams out of that 5 grams is going to be nitrogen? So you'd have to be given the percent, or you'd have to have already calculated it. But knowing that it's 29.15%, you can just set up a ratio, right? This always works for percents, right? It's just, I don't know what the part is. I know what the total mass is, but if I solve for X here, it would tell me what part of that 5 grams is actually nitrogen, right? So it should be somewhere close to 1.5 if you calculate it, because I'm pretty sure that 30% of 100, 29.15 is pretty close to 30, right? If I just work my way backwards and backtrack, 30% of 5 is about 1.5. So it'd be close to that answer. It's not exactly, but I'll let you check that out for yourself. Otherwise, percent by mass iron and ferric sulfate, another one we already did, right? So we know that iron sulfate that looks like this has a mass of 399.91 grams, and I got 2 irons that I'm accounting for here, so it's 2 times 55.85 gives me, what is that, 110, so I think it's going to be 111.7 on my calculator, right? I didn't actually use a calculator, but if I did, it'd look like this. Now this is what I talked about in class 2. Remember, this went to 2 places past the decimal. You actually do need a 0 here. Don't lose significance because your calculator doesn't show you that 0. So I am going to use this number, divide it by 399.91, take it times 100, and that'll give me my percent. So when it's all said and done, it's going to be pretty close to 27.933%. Not exactly that, because I didn't use the same number as we did in class. Your periodic table has a slightly different number for sulfur than mine does, right? The periodic table that I checked before had a 0.6 and not a 0.7, so you might get a slightly different answer, but go ahead and work that out. It should be close to 27.933 0.33, but again, I actually used a slightly different number for this. So I had a 399.88. So it's probably different, but you can fix that yourself. Just make sure it has 5 sig figs, like mine. Otherwise, the last problem, if 1 mole of a sample of hydrated cupric sulfate has a mass of 249.71 grams and is heated to produce 159.62 grams of anhydrous cupric sulfate, how many moles of water molecules are present in the hydrated cupric sulfate? So hydrated just means that it has water, right? Anhydrous means no water, right? Notice there's no water in this formula. So the difference between those two things is the water, which should give you a pretty big hint as to what you should do with these two numbers. Right? When I say difference in math, I mean subtract them. So when I subtract those two numbers, I get a 90.09. So we just need to know that that's what we're going to do in this style of problem. But then that 90.09 is the mass of my water, and I need to figure out how many moles that is. Again, if you check with your notes before this problem, I'm pretty sure we found out that water was 18.02 grams per mole. So if I divide here, I'm going to actually get like 4.999 with 4 sig figs, because that would be an appropriate amount of sig figs for this situation. But actually the answer is supposed to be a whole number when you're talking about an n value like this. So this n is the amount of moles for that water. And that n number in a formula has to be a whole number. So actually this is really, really close to 5. And 5 should be the answer, right? N equals 5 for this situation. We actually looked at this in class and saw that that cupric sulfate looks different than the anhydrous version, right? One's this bright blue color, right? The other one has that kind of grayish greenish, right? And so there is a difference, a noticeable difference when you drive off all that water. But we also proved in class that it definitely has 5 moles of water that gets pushed off. But otherwise, you need to know how to do the calculations. All right, so that's good for this video.